Well, welcome to today's lesson. I'm Siamasaka Kirendens, and so I'm going to take you through a lesson in physics. So we go straight into the lesson. As I indicated, I'll say that actually I'm going to take you through a lesson for today. And so if you want to contact me on one-on-one lessons, you can contact me on this WhatsApp number. Plus 260 977. This is 977 41 9949. And so we can arrange for a one-on-one lesson if you so wish. And so we're going to straight into the lesson. So we are solving a question here. From an initial velocity of 2 meters per second, Konaka accelerates uniformly at 2 meters per second squared until he attains a maximum velocity of 10 meters per second. He maintains this velocity for 2 seconds, and he then decelerates uniformly for 4 seconds. Draw a velocity time graph. Okay, so the second question, calculate the distance when Konaka was actually accelerating. Also, calculate the distance Konaka covered when he had constant velocity and when he was actually decelerating. And so when we are confronted with the equation like this, first of all, we write actually the title of what we are asked to do. So we are required to actually draw a velocity time graph. So you write the title that actually we are drawing a velocity time graph. So we have, this is a straight line, the y-axis and the x-axis. On the x-axis, we have actually time. We write time in seconds. You write the units. And on the y-axis, we have actually velocity in meters per second. So we go back to our question. We are told that actually Konaka accelerates uniformly at 2 meters per second squared. His initial starting velocity, which is the initial velocity, is actually 2 meters per second. And so we assume that here, this is our 2 meters per second. And then he is accelerating uniformly until he attains a maximum velocity of 10 meters. So he's accelerating uniformly until he reaches the velocity here, which is 10 meters per second. Okay. And so we need to find, they have not told us the time he covered actually while he was accelerating to move from 2 meters per second to his final velocity, which was 10 meters per second. And so we need to calculate this time. And so we are aware that the acceleration is equal to final velocity minus initial velocity over time. And so we can tabulate the data of what we are given in the question. So on the first part, we are told that the initial velocity is 2 meters per second, and the final velocity is 10 meters per second. And the acceleration is 2 meters per square second. The time, we do not know. And so this is the only one we can calculate, and therefore you can put your 2 there, which is your acceleration, and your final velocity is actually, from the equation, it is 10 meters per second. So, which is 10 minus the initial, which is 2. Divided by the time we don't know. So we have 2 is equal to 10 minus 2 is 8 over t. So we can cross multiply to calculate t. So 2 times t would be equal to 8 multiplied by 1. And therefore our t is equal to 8 divided by actually 2, which is equal to 4 seconds. And so we can now put our time there, actually that this is 4 seconds. We can go back to our question. He maintains this velocity for 2 seconds. So Kunaka moves with this constant velocity for 2 seconds. So he moves with this velocity for 2 seconds. And so if you add 2 seconds plus 4, it means that actually it is 6. Then we go back. He maintains his velocity for 2 seconds and he then decelerates uniformly for 4 seconds. So uniformly means straight uniformly for 4 seconds. So if you add 4 seconds plus 6, it means that that would be 10 seconds. It means that now we have actually completed drawing our velocity time graph. So we go to the second question. Second question, calculate the distance when Kunaka was accelerating. So from the graph, the point when there was acceleration is actually this point here, when he moved from 2 meters per second to 10 meters per second. Because acceleration actually is the increase in actual velocity. There should be increase from a lower velocity to a higher velocity. And it took actually 4 seconds. So we can calculate, according to this, they're saying you calculate the distance when Kunaka. So the distance here is actually the area under the graph. So we can have 2 distances here. For a rectangle, we can call it distance 1. And for the triangle, we can call it distance 2. Then you add this distance. It means that we have actually calculated the distance Kunaka actually covered while he was accelerating. So, so we are saying distance covered during acceleration would be equal to actually the area under the curve. The area under the graph. And we have already partitioned that the area under the graph is distance 1 and distance 2, which is actually the area under the curve for distance 1 and distance 2. And you notice that for distance 1, the area here will be that one of a rectangle, which is the length multiplied by the height. And you notice that here, the length is actually 4 seconds. Is actually 4 seconds multiplied by the height, which is actually 2 seconds. Okay, which is actually 2 seconds. So we have 2 meters per second, which is actually, the height is actually the velocity. And what you find here is that the second and the second are going to cancel. So what we're going to have is 4 times 2, which is actually 8 meters. So the distance covered for D1, actually for this area under the graph, is actually 2 times 4, which is actually 8. So we get also the area under the curve for the triangle. So for distance 2 would be equal to area of the triangle. And this triangle is actually a right-angled triangle. So our distance 2 would be equal to half the base multiplied by the height, which is equal to half multiplied by, if you look at the base, it is actually 4 seconds. 4 seconds multiplied by the height. If you look at the height of this triangle, it would be 10 minus 2, which is actually 8 meters per second. It will be 8 meters per second. This second and this second are going to actually cancel. 2 here, 1. 2 here, actually 4. 4 times 4, it gives us actually 16, which gives us actually is equal to 16 meters. That is actually distance 2. So the total distance now covered when the Kunaka was actually accelerating, it is the addition of the total distance, total distance, the distance which is total would be equal to distance 1 plus distance 2. So distance total would be equal to the addition of distance 1 plus the addition of distance 2, which we have found distance 1, we found 8 meters. 8 meters plus distance 2, actually we found 16 meters. 16 meters. So when you add, you actually find 24 meters. So this is the total distance which was covered when actually Kunaka was accelerating. So we go and answer the other question. Calculate the distance Kunaka covered when he had constant velocity. So when he had constant velocity, it is this period between 4 seconds to 6 seconds. And this is actually a rectangle. So we can call this one as distance 3. Okay, and so we can say distance during constant velocity. It will be equal to actually, which we have called distance 3, will be equal to the area under the curve. Area under the graph, which is equal to area, which is L multiplied by the height. And we note that here, the length is actually 6 minus 4, which is 2 seconds. Which is equal to 2 seconds. And the height, we note that it's actually 10 meters per second. 10 meters per second. So this second and this one will cancel. And this gives us actually 20 meters. So this is the distance that was covered by Kunaka when he actually was moving with the constant velocity. So we go to the other part of the question. When he had constant velocity and when he was decelerating. So we need to calculate the distance when Kunaka was actually decelerating, which we can denote by distance 4. And it's actually for a right-angled triangle. And we see that the base here is actually 10 minus 6, which is 4 seconds. And the height is actually 10 meters per second. So distance during uniform deceleration. Okay, so we have called this distance as the distance actually 4. So this distance 4 is equal to the area of a triangle, which is half base multiplied by height. And we note that our base here, as we said, it's actually 10 minus 6, which is 4 seconds. 4 seconds multiplied by 4 seconds. And the height is actually 10 meters per second. So we have 10 meters per second. And this second are going to cancel. 2 here, 1, 2 here, 2, and 2 times 10 is actually 20 meters. So distance 4 is actually 20 meters. This is the distance covered by Kunaka when actually he was decelerating. And this is the last part of the question actually, which we have actually attended to. I thank you.